What is up, everyone? Welcome to today's video, and as you can see, I had to bring out the whiteboard because we're going to be solving a hard Leetcode problem today, which is finding the median of two sorted arrays. So let's say you're given 1, 3 as your first array and 2 as your second array, right? Clearly the median between these two arrays is 2, right? Because 1, 2, 3, the median is 2, right? So one approach of how you can actually find the median given two sorted arrays is to use a brute force approach. So you basically say, hey, you know what? I'm going to merge these two arrays, and you basically have one sorted array, and you're basically just going to pick out the median, right? So this is a solution. It's not a bad solution, but it's not a great solution either because it's running in linear time, and we can actually solve this in logarithmic time complexity. So how do we actually solve this problem? Well, let's say you have two arrays, right? First one is A, and you have elements A1, A2, and A3, right? The second one is B, and you have elements B1, B2, B3, B4, B5. The basic idea is you want to basically partition these two arrays into two halves. And each half is going to have the same number of elements, and you'll see how it's going to be different with odd number of elements. But in this case, right, you have 8 elements, so 1, 2, 3, and you have 5 here. That's 8 elements. So you're going to partition it into two halves. Each half is going to have 4 elements, right? Because that's equal, right? Each half is going to be equal. And then the most important part, though, is that the left half has to have all the elements smaller than all the elements on the right half, right? So let's say you want to partition this array right here. So what that means is now that A1 is in the left half and A2 and A3 are in the right half. And then because I partitioned it here and now I have one element in the left half, I need to partition this array here and have 3 other elements in the left half. Because remember, you want to have 4 in the left half, 4 in the right half. So now we have 4 in the left half, A1, B1, B2, B3, and then A2, A3, B4, B5 are in the right half. So the most important part, though, is that A1, B1, B2, B3 must all be less than the elements in the right half. So basically how you can find this is you basically compare. You know that A1 is less than A2, right? Because it's a sorted array. But you need to compare and check if A1 is less than B4. So if A1 is less than or equal to B4, and similarly, you know B3 has to be less than B4 because it's given to you sorted. So you have to check if B3 is less than or equal to A2. Once you get to this point, you're good. You basically found the where you can partition, because what you're going to do now to find the median is if it's an even number of elements, so let's say here you have 3 plus 5, that's 8, so the total number of elements is even, then what you want to do is you want to actually find the maximum number between the left partition in the first and the second array. So which one is greater? Is A1 or B3 greater? You want to find the maximum. So you basically do maximum of A1 and B3, right? You want to find the maximum, right? It's closer to the middle if it's the maximum, right? And then you want to find the minimum of A2 and B4, because again, the minimum is going to be closer to the middle, right? So the minimum of A2 and B4, right? So now what? Now you have two numbers. You get a number from here, which is the maximum, and you get a number from here, which is going to be the minimum of the two numbers. Now, all you have to do is add them together, divide by 2, or basically find the average, and that's your median. You're done. So some of you might say, well, okay, that's for an even number of elements. What about if it was an odd number? So if it's an odd number, the only thing that's going to be different is the fact that, so let's take an example. Let's say this is actually, okay, so this is B3, B4, right? So clearly this is even because you have 7. So the only difference here is you're going to have an extra element on the left side, right? So say again, I partition here. So we have 7, right? So if you have it half it in the middle, you have 3 and 3. But like I said, you're going to have one extra element on the left-hand side, so you're going to have 4 on the left half. So because I want to have 4, I'm basically going to partition it here, and now I'm going to have these elements on the left side, and then these 3 elements on the right side. So the reason for this is what you're going to be doing now is you're basically going to find the median from these elements, right? And the difference is that you're going to basically have 4 elements, and you basically will find the median within those 4. You don't need to actually basically do an average with these 2 other elements, right? Once you get to this point, but it still maintains that this A1 has to be less than or equal to B4, and this B3 has to be less than or equal to A2, right? The only difference is, like I said, once you get to this point, right, what you do is you just find the maximum of A1 and B3, and the maximum is going to be your median because you basically found that number in the middle, right? Say you have 1, 2, 3. Essentially, let's say your left half is going to have these 2 numbers, and you basically find the max of these 2, which is going to be 2, and you found your median, right? So that's basically how it's going to work conceptually. How we're going to solve this is we're basically going to be using somewhat of a binary search. So we're going to keep checking and finding different partition locations until we reach that partition location such that all the elements on the left-hand side are less than all the elements on the right half, right? Once you hit that point, we find that partition, you're done. And how we're going to find that partition point is using a binary search. And we're just going to go through an example, and then we're going to actually go ahead and code it. Alright guys, so let's actually look at an example. And let's say you're given an array A with 3 elements, and an array B with 5 elements. So essentially what you want to do is, you want to, again, find the median, right? So if you had a merged, sorted combination of these 2 arrays, you would have this, and the median would actually be the average of these 2. So 6 plus 7 divided by 2 gives you 6.5, right? So our aim is to do this using the approach we just talked about, and we essentially want to binary search this shorter array until we get the location or the places where we can actually partition it such that the left half and the right half actually have equal elements. If they're even, if they're odd, the left half is going to have 1 extra element. And the most important part is that the left half has all the elements such that their value is less than all the elements on the right. So how we can do this is we want a binary search, right? So we're going to start off with 0, and the high is going to be the length of the array, so it's going to be 3. And then this is going to allow us to basically figure out where we're going to start the partitioning for the first array. So it's actually going to be 0 plus 3, or low plus high, divided by 2, which is equal to 1, because 3 divided by 2 is 1.5, which is going to round down to 1. So we're going to put a partition in here. So what that means is there's going to be 1 element on the left half, which is what we have, which is 1. We're going to use this to figure out where we should partition B. So remember, we want to have equal elements on each half. So the left half should have 4, and the right half should have 4, because we have 8 elements in total, right? So essentially what you want to do here to find where you can partition B is you want to figure out how many more elements do I need to get basically 4, or the equal amount. And so what you can do is you can say 3 plus 5. So the length of the array A and the length of the array B, so 3 plus 5, plus 1, and you'll see why in a second I added 1, divided by 2 minus partition A. So what this is doing is it's saying that how many more elements do I need to get from array B and put it into the left half, knowing what I know, knowing that I actually have partitioned at A. So you want to actually get the lengths of the array A and array B, which gives you 8, and then you want to actually add 1. So the adding of 1 is actually just so that this works for both cases where you have a sum that's actually even, like in this case, and a sum that is odd. So what this does is when the sum is actually odd, let's say we have another example where we have like, let's say 4 and 5. So the sum is actually 9, so that's odd. In that case, remember we want to have an extra element on the left half. So this ensures that we're going to have an extra element on the left half. And you'll see when we have an example with an odd sum. So essentially what you're going to have is you're going to have 8 plus 1, so 9 divided by 2, it's going to round down to 4. 4 minus 1, so you know that you should partition at 3. So here. And this is exactly what we need, because remember we want to have 4 elements on each half, and this basically gives us 1 element here and 3 elements here, so that's 4 elements on the left half. Okay, so now what? Well, now we have to actually check, right? We have an equal amount of elements, great, but we want to actually check is, since we know that this element is less than this element, and this element is less than this element, we actually have to check, is this element less than this element, and is this element less than this element? So let's actually just write this out. And basically we're going to have 1 here, 2, 6, 8 here, right? And then on this side, right half, we're going to have 3 and 7, and then 9 and 10. So now we can check. Is 1 less than 9? Well, it is, great. Is 8 less than 3? Actually, it's not. So what does this mean? Well, clearly, 3 is too small. 8 is greater than 3. So how we can do this is we can move our search to the right. So essentially what we're going to do is we're going to move our search to the right. So what we're going to do now is we're going to change the low point to be partition A plus 1. So we're going to add 1 to the partition and set that to be the value of low. So 1 plus 1, 2. This is not going to change. And then this is going to change though. It's now going to be low plus high, which is 5, divided by 2, which gives you, it's going to round down to 2, right? Because 5 divided by 2 gives you 2.5, which is going to round down to 2. And so the partition of A is going to change to here, such that there is now 2 elements from array A into the left half of the partition. And of course, partition B is going to change as well, because now it's actually 9 divided by 2, so 4 minus 2, which is actually going to be 2. So now this is also going to change, and it's going to be 2. So now the elements on the left half are actually 1, 3, 2, 6, and then 7 on the right, 8, 9, 10. So now we do a check again. Is 3 less than 8? Well, it is. Is 6 less than 7? It is. So now we're done. We are at the location that we want. Now we can actually do what we talked about previously, which is find the minimum and the maximum, and then find the average of the two numbers. So what this means is, remember guys, we need to find the maximum of these two, right? And the minimum of these two, and then find the average of the two. And why we're doing this is because the maximum of these two is going to be closer to the middle, which is closer to the median, right? Because think about it, as you can see here, 3 and 6, the maximum is closer to the middle, which is what we want. The minimum here is closer to the middle, which is what we want. So clearly the maximum here is going to be 6, and the minimum is going to be 7, as you can see here. And then we find the average by dividing by 2, and we get our median. So that's it, we're done. So this is an example of where you have an even sum of elements in two sorted arrays, and this is how you would solve this. So we actually want to go over an example where we have an odd sum, just so we can actually understand the significance of +1 and just how this is slightly different. The end calculation is slightly different, and also there's an interesting case that we can actually consider. So let's actually just scrap this whole thing. And essentially, we're going to go with a pretty simple example. We're going to go with actually the example that's asked on the Leetcode problem. So it's actually, it was A is equal to 1 and 3, B was equal to 2, right? And essentially, obviously, the sorted array would be 1, 2, and 3. Clearly, the median would be 2, right? So, same concept here. The low is going to be, so we're going to do binary search on the smaller array, so this one. So low is going to be 0, high is going to be 1, right? Partition A is going to be 0 plus 1 divided by 2, which gives you 1 divided by 2 is half, which is going to round down to 0 if it's an integer. So now we actually have a partition here. So what that means is there's actually no elements in the left half, right? And this is kind of different. This is kind of an edge case, right? And the partition B here is going to be the length of, so 2 plus 1 plus 1 divided by 2 minus partition A, right? So now you can see that actually the significance of this one is that we want to have an extra element on the left half, right? So what that means is 2 plus 1 is 3, and then add an extra 1, so now you get 4. 4 divided by 2 gives you 2. 2 minus 0, so the partition is actually going to be here. And you're going to have two elements in the half, just like we want, because we want the left half to have one extra element than the right half in the case where it's an odd sum. So essentially we're going to have, the right half is going to have 1 and 3. Wait, let's just keep, yeah, okay. So let's consider that the top is the shorter array, right? Oh wait, sorry, that's not what I meant. Here, right? So then, well, what about this side? There's nothing on the left half, so what should we do here? Well, this is the edge case I was talking about. In this case, there's nothing there. So essentially what we can do in our code especially, we can say that we can consider that this is the minimum integer value, which is basically going to be negative infinity. So this is going to be negative infinity. And this is a similar case. In the case that, you know, your partition A is actually at 0, you know that it's going to be negative infinity here. In the case where it's actually, partition is actually at the length, which is 2, so this is 2, right? So in the case where the partition is equal to the length of that array, so 2, then this is going to be positive infinity, right? Because there's nothing on the right, right? So essentially now, what we're going to do now is we're going to say, okay, is negative infinity less than positive infinity? Yeah, it is, okay? And is 3 less than 2? Actually, it's not. 3 is not less than 2, right? So the same thing that we did before is we're going to actually move this to the right. So now we're going to move this to the right. So essentially what we're going to do now is we're going to change this to be partition A plus 1. So 1. High is not going to change. This is going to change though. So now we have 2 divided by 2, which is 1. This is going to be 4 divided by 2, 2 minus 1, which is going to be 1, right? So this changes things a little bit. Now the partition A is actually going to be here, right? So 2 is actually included here. And then this is actually positive infinity because, right, it's equal to the length. The partition A is equal to the length of this array. And then this also changes the partition B. So essentially what's going to happen now is we're going to have the partition B at 1. So what's going to happen is 1 is going to be here, and then 3 is going to be here, right? That's what's going to happen. And now we can do the check again. Is 2 less than 3? Yeah, it is. Is 1 less than positive infinity? It is. So now we got what we need, and we actually need to do this thing we talked about, is instead of figuring out what the max is here and the minimum here, since we have an odd number of elements, we just need to find the max of these two elements. So we just need to find the maximum of these two elements, and that gives us the median. So the maximum of 2 and 1, sorry. The maximum of 2 and 1 is 2, right? And that is exactly our median. So you notice that there's two things that they're done differently here. First of all, you can see the significance of +1. You need this to ensure that the left half has an extra element, and it needs to have an extra element just because you basically, the way we're solving it is we're finding, if it's odd, we're basically having the median inside the left half, and you're basically going to figure out which one it is. And if you basically don't add +1, what's going to happen is you're going to have one less element in the median, and possibly you might miss the median, and it can mess things up. And you can actually try without the +1. You'll notice that this actually won't work, and you're going to get the wrong answer because you're going to be basically skipping it. And so what's going to happen now is, other than that, the difference is that you saw the edge cases, right? So in the case that the length is actually equal to the partition, right, then it's going to be positive infinity. And the case where the partition is equal to 0, it's going to be negative infinity, right? So the other case that we actually didn't consider yet is in the case where, so we've seen a case where this was greater than this, right? So like the previous case, right? We had 3 here, and then we had 1 here. We had 2 here, right? So 3 was greater than 2, so we moved this to the right. So yeah, and sorry, we moved this to the right. We moved the binary search array. We moved it to the right. So in the other case, where this element here, so let's say this was 3 and this was 2 in another example. If this was the case, 3 was greater than 2, what you would do in this case is you would move the binary search backwards. So, I don't know why I erased the whole thing, but essentially if this was here, you would basically make this, you would say hi, you would -1, so this would become 0, you say -1, and essentially this would move backwards. So this is not applicable to this situation. I'm just explaining if you had a case where this element, the maximum element of the left half was greater than the minimum element of the right half here, then you basically, instead of adding 1 like we did previously in an opposite case, you would subtract 1 and move it backwards, right? And don't worry, we're actually going to be writing the code right now, so you're going to see the 2 cases, right? If it's greater than, you would do this, and if it's less than, you would do that. So now we're just going to write the code, and we're just going to go through this exact concept, but in code.
Alright guys, so the first thing we want to do is we want to make sure that the first array is actually smaller than the second array, because we want to do binary search on the smaller one. So we're going to do our code as if the nums1 array is actually smaller. So we can just add a check in the beginning saying if nums1 dot length is actually greater than the second array, then we don't actually want to do the calculation on the first one. So instead what we can do is we can recursively call the function again, and we're going to basically switch out the parameters. So basically, since nums2 will be smaller in this case, or smaller in this case, we're going to actually put that in the beginning, and we're going to recursively call it, right? Okay, so now we have that out of the way. What we can do is we can actually define a few variables. So the first variable we're going to define is the length. So I'm going to call the first array A and the second array B, just to be consistent with the explanation on the whiteboard. So nums1.length, and then length B, which is going to be the length of the second array. Okay, and then we're going to actually define the variables low and high, and low is going to start off being 0, high is going to start off being equal to the length of the first array A, which is going to be the array we're going to do the binary search on. And then we can actually start the search, or we're going to iteratively partition until we find the location that is where the median is actually there. And essentially what we're going to have is we're going to have a condition where low is less than or equal to high, and then once we're in here, we have to actually start by partitioning, finding a partition for the first array A. And remember, if you recall, that's actually going to be just low plus high divided by 2, right? And then partition B was actually that, remember that equation, that formula we had, which is basically just the length of, so basically the sum of all the elements, so length A plus length B, and then basically plus 1, right? So essentially what we're doing is we're saying, okay, I know that I have to partition here for A, and I have this many elements that are going to be in the left half. So knowing what I know about the partition A, how many elements do I need to actually get from B? And so where should I partition, basically? So once you do that, you divide by 2, and then you subtract partition A. So remember, the plus 1 was just to make sure that this works for both odd and even, because in the odd case, we want to have an extra element on the left half. Alright, so now we have that done, and we essentially want to define the variables, so the maximum values in the left half for both the array A and B, and the minimum values in the right half for both array A and B. So we can define maximum left A, which is basically the maximum elements in the left half from the elements in array A. So that's going to be equal to, now there's an edge case where you can actually have the partition A being 0. And remember, if that was the case, what we have to do is we set that to be negative infinity. And how you can do that in code, you can just say integer.min value, and that's basically what it is. Otherwise, if it's not 0, that means there are elements to the left of this partition, and so we want to get the maximum of those elements from the array A. So we can do is say nums1, and you want to get the element at index partition A minus 1. So the reason there's minus 1 is because if you remember how partitioning works, let's say you have a partition at 1, that means there's one element to the left, so the index would actually be minus 1. And then we have to actually find the minimum element on the right half for the elements in array A. So similarly, there's another case here. If the partition A is actually equal to the length, then that means it's actually, there's no elements to the right of this partition, which means that we can set it to be positive infinity. Otherwise, we can actually have the element at index partition A and not minus 1 because it's to the right of the partition, right? So the index is going to be equal to partition A. So now we've done that for the elements on the left half and the right half for array A, but we have to do that for the elements in array B as well. So we can just copy paste this, make sure we just change this to be B, and a few changes here as well. So it's just the same exact thing, except we're going to be dealing with the second array and partition B, right? Oops, nums2. I would recommend not copying pasting, but just that because this video has been going on a while, so just to make sure this goes well, I need to check. So yeah, so if it's 0, that means you're going to basically set it negative infinity, otherwise you get the value here. Same thing here, positive infinity, get the value. Okay, great. So I just forgot to add here length A, length B. Okay, so now we actually have the values, and we just want to check. You want to actually check, is the element max left A, is the element, the maximum element in the left half from array A, is it actually less than or equal to the minimum element in the right half for array B, right? And then we want to make sure that the same case is true for the other element. So min right B, and the maximum element on the left half, but this time from array B, or the second array, has to also be less than or equal to the minimum element in the right half from array A, right? If this is the case, that means we're actually at the partition we want. We actually can calculate the median now. So we have to consider two cases. First of all, if it's there's a sum that's actually even, we have to do we have to basically find the maximum and the minimum, and then find the average of the two. So how we can check if it's positive or even, we can just positive even, odd or even. We can just say length A plus length B and modulus 2. If that is actually equal to 0, there's a remainder of 0, that means it has to be even. So in that case, we're going to return a double. So we're going to typecast, we're going to cast the value to be a double because that's what it's asking for. And essentially what we're going to do now is we're going to say math.maximum. So we want to find the maximum of the two maximum elements in the left half. So I want to find the maximum of left A and the maximum of left B, right? And then essentially what's going to happen now is I'm going to get the maximum because it's closer to the middle, and I'm also going to get the maximum, the minimum of the right half, right? So I'm going to say, give me the minimum of the right from array A and the minimum of the right half from array B, and whichever one's going to the minimum is going to be closer to the middle, right? And I'm going to divide by 2, and then this should give me the answer, right? So the average of the two. In the other case where it's actually an odd sum, we basically just need to find the maximum of the two elements in the left half, because left half has an extra element. So we just need to say, give me the maximum of the left half, and so the maximum of left A and the maximum of left B, that should be the median, right? So in the other case where we're not actually in the right position and we need to actually move left or right, we need to consider those cases. So else if the case where the element at max left A is actually greater than the element at min right B. So essentially what that means is, so A is the array that we're doing the binary search on. So we're saying that the elements, the maximum elements in the left half of A is actually bigger than the minimum elements in the right half of B. So what that means is that we're actually too far ahead. We need to actually, dial it down a little bit or move the search backwards. So how we can do this is we can say high is equal to partition A minus 1. So notice in the, I accidentally made a mistake in the video. I said it should be high minus 1 instead of partition A minus 1. So this is how it should be. Otherwise, there's another case which we saw in our examples, is if actually the element at max left B, so not the array that we're actually doing the binary search on, is actually greater than the minimum element in the right half from the array A. So in that case, we're actually too far behind, and we need to actually move the search forward, so we can actually change the low variable to be partition A plus 1, right? So in that case, we're going to move it forward, and the value should become bigger. And this is exactly what we saw in the examples we've shown. We had to actually move it plus 1. So now we actually have all cases covered. And then essentially what we're going to have to do is just add this one check to make sure if they were given a case where it's not sorted, we can just throw an exception, right? Just to say, but I mean, they told us it's going to be sorted and stuff, so now we can actually try running this, and hopefully there's no errors. We might have missed something, but okay, let's try submitting it. And great, it works, right? So as you can see, the runtime is actually great. It's almost 100% more than all submissions, only 2 milliseconds. So it should be logarithmic. And this is how you would solve this. So thanks for watching, guys. Make sure to, if you're confused or stuck, make sure to go back and review those things. It's very detailed. It's a very detailed video, but this is a hard question, so I need to make sure that you guys fully understand the logic behind it. So make sure to like and subscribe, guys, and comment down below any tips or advice, suggestions or feedback, or other questions that you'd like to see in future videos.